In this tutorial, we're going to talk about mass and volume. Mass and volume are related by density, and we know that the density equals the mass per unit volume. In this way, the units are kilograms per cubic meter, or we can have pound mass per cubic foot. Well, it depends, right, on the system that we're working. And there are equivalences between these two systems, say international system and English system. Sometimes you can find the term specific gravity, and the specific gravity is actually the density of any given substance with respect to a density of reference, usually the density of water. So it is important for us to understand that the density of water that we usually use is 1 gram over cubic centimeter, or 1,000 kilograms over cubic meter, or if you want to state this in English system, 62.43 pound mass per cubic foot. So if you want for any given substance, you want the density, right? What you're going to do is multiply the specific gravity, if you are given with the specific gravity, times the density of H2O of water, then you can have the actual density of this substance. We also know variables that are actually flow rates, and we have the mass flow rate, so that's the amount of mass, kilograms, per unit time, let's say seconds, or pound mass per second, or per minute, or it's the amount of mass per unit time, while the volumetric flow rate is the amount of cubic meters per second, or of cubic feet per second, or any given volume per unit time. In this sense, the density is going to be equal to mass per volume, but also the mass flow rate over the volumetric flow rate. And we use this point above the letter in order to indicate that this is a flow rate, okay? In order to measure the flow rate, we usually use the flow meter. One of them is the rotameter. The rotameter is a device where you have an input and an output, and we have a float, which is usually a ball or something. So if the flow rate is higher, then this float will rise in the tube, and then it can be calibrated in order to have a scale, right? We also have the orifice meter, and usually you put an obstruction in the channel where is flowing the fluid, and the pressure will decrease. And this decreasing pressure at the other side will have a differential manometer, and then this difference in pressure will tell you how is the flow rate at the beginning and at the end. You might actually remember this as a Venturi tube.